வீட்டு வேலை முடிஞ்சிருச்சு. எங்க அம்மா ஒரே மாதிரி அடிக்குது. என்ன பண்றது? வேஸ்ட் பண்ண முடியாதே. அப்படின்ட்டு எல்லாம் காடு போட்டு குத்தியாச்சு. இதெல்லாம் ஹேண்ட்மேட் ஹோம்மேட்.
Hi, good evening. Thank you for joining. We'll wait 2 more minutes for the others to join. Okay. Good evening. Let me give a small brief introduction. So for others to join also, it will be fine. Those who are joining you today, let me introduce myself. This is Saravanan, PMR scholar and PhD scholar at NIT Tiruchirappalli, Department of Civil Engineering. And this is the problem solving session for the NPTEL course, wastewater treatment and recycling. So I am taking this course as a part of my PMR of TA ship as a deliverable. So this is my fourth NPTEL course. I have already taken integrated solid waste management, air pollution and control, as well as plastic waste management. You can go through the YouTube videos. And this is my fourth session, and we are in the 8th week of this course, wastewater treatment and recycling. Okay, so this course was actually taught by Dr. Manoj Kumar Tiwari sir from IIT Kanpur, and all the presentations are credits to him only. Okay, so this session will be of 2 hours. First 1 hour, I am going to um, take the same lecture material what sir has taught in the YouTube classes, and another 1 hour we are going to see the old assignment problems. Okay, how to solve that and all. So first 8 weeks we have discussed about what is wastewater treatment, why we need to treatment, what is the consequences if we are not going to treat, if we are not treating the wastewater, if we are discharging directly into the surface or groundwater bodies, that we have discussed in the first week. Second week we need to know how much quantity it's generating so that we can design the wastewater treatment plants, right? So quantification based on the population we have discussed in the second week. Third week we have discussed the quality of the wastewater based on the characteristics of the wastewater, like physicochemical characteristics and biological characteristics of the wastewater. And in the fourth week we have discussed the environmental and the human health impacts of the wastewater treatment, wastewater discharge. And fifth week we have discussed about the primary treatment systems, like primary and as well as the preliminary treatment system, like that screening, grid chambers, and primary sedimentation tank along with the equalization tank. And sixth week we have discussed about the secondary treatment, that is biological treatment. Sixth week is on aerobic treatment, that is activated sludge process, and seventh week is on anaerobic treatment, that is post ups we have discussed in the last week, right? Anaerobic digestion. The eighth week we are going to discuss about the sludge management. All this process what we have discussed produces some sludge, right? So that sludge how we are going to manage, that's what we are going to see in this eighth week. So welcome to the eighth week of this course, NPTEL course, wastewater treatment and recycling. Let me go through the lecture materials. Okay. Yeah. Hope my voice is audible and my screen is visible. Let me start. So, coming to the eighth week, this week we are going to discuss, as I mentioned, it's all about the sludge management. So, all our treatment process, like what we have discussed, the screening, after entering into the screening, it will go to the grid chamber. After removing the readily settlable solids, it will go to the primary settling tank. There, it will remove the organics, I mean, suspended organics that will get settled, and then it will go to the, this all will be preliminary and primary. After that it will go to aeration tank and secondary sedimentation tank, that is aerobic treatment. Here there is no settling, it will be full of aeration mixing, and here it will be settling. The secondary sludge will be having dissolved organic matter, that's biomass. Okay, and after that it will go to maybe instead of that we can go with the anaerobic digester, and then it will be disinfected and disposed in the river bodies or lake or agricultural land. So all this process, if you see, grid chamber there is a sludge, primary settling tank there is a sludge, and secondary settling tank there is a sludge. What can we take up, where can we send this type of sludges and where it will go, how to manage that sludge, that's what we are going to discuss in the eighth week of this session. Okay, so sludge management, this is an important topic. Coming to the system, if you see, screening, primary sedimentation, aeration, final settling. From the final settling tank, there will be some sludge that will be returned to the aeration tank. That's called the return activated sludge, right? And some will be wasted, that is waste activated sludge. And from the primary tank also some raw sludge will be settled. And screening also will produce, screening also will produce some sludge. And then primary grid chamber will also produce some sludge. All the sludge will come as wastewater sludge for processing. So how we are, if some treatments, tertiary treatment with the chemicals are required, that also will produce some sludge, that is chemical treatment sludges. Okay, so sludge, any conventional biological wastewater treatment process, although efficient in removing organics, they generate a large quantity of excess sludge because we are using microorganism for the removal of organics. It will eat the organics, it will grow, its cell mass will increase, right? So new cells will be produced. After new cells are produced, the old one will die. So that whole system, bulged biomass, as settle as a suspended solid. That's why a large amount of sludge will be produced in biological treatment process, that is especially in aerobic treatment systems. Anaerobic will produce only less sludge, like 5% or something, but aerobic sludge will produce 45% of sludge, right? That's what we discussed in the last week. So sludge refers to residual semi-solid material, so that will be settled by product. and from different treatment plants, right, systems. So quantity of sludge will be based on the degree of treatment what we are doing. If we are treating only 50%, then 50% will be coming as sludge. If you are treating 70%, then 70% will come as a sludge, right? So that quantity of sludge is based on the degree of treatment. And if you don't think sludge management as a simple task, most of the cost for the treatment plant, 50% will be for sludge management. Then sludge handling itself accounting for 50% of the total cost of sewage treatment plant. And think about the total cost. If you are spending like 10,000 for treating this much of water, 50,000 for the 5,000 will go only in sludge handling. Then this is a big matter, right? So same. If you think about solid waste management, people are thinking after collection what they will do. We need money for treatment of waste, composting or anaerobic digestion or what we say incineration, burning, whatever we need money, right? But like statistics shows 50% of the total cost is only for collection, then remaining 50% is for treatment and all, like transport and itself, collection and transport itself will cost 50% of total cost. Then think about how much municipals are spending on collection and transport. That's what similarly in sludge management 50% of the total cost is on sludge handling. You got it? Yeah. So where are the just sludges are getting generated? Preliminary treatment, primary treatment, that is a primary sludge. In secondary ASP tank, after recycled activated sludge, some will be waste sludge, that is secondary sludge. So primary and secondary sludge, some if you are doing any tertiary treatment with the chemicals, that tertiary sludge will also come. Sludge is generated from primary and secondary treatment plants. Primary sludge will be uh, like primary and secondary treatment will give you primary sludge, and secondary sludge and activated waste activated sludge. So these three are the types of sludges. I mean, two are the type of sludges. Secondary sludge will also called waste activated sludge. And if any tertiary treatment will also contribute, that is called a tertiary sludge. Yeah, what is the characteristics of the primary sludge? As I mentioned, primary settling tank will only remove the readily settleable organic solids. So mostly it will be organics and some inerts will also settle, similar to grit chamber. And then secondary settling tank will be after biological treatment. So mostly it will be organics only. Dissolved organic will form biomass and that will settle. So mostly secondary settling tank will have organics. So primary sludge, if you it will be composed of settlable solids from the raw wastewater. So in the sedimentation at times in the grit chamber also it will compose. So it will be grit chamber fully inorganics. Sedimentation it will be organic but suspended, right? So the generation range, if you see 100 kg and average 110 to 170 kg per million liters. Okay, from municipal solid waste. So if you have a plant of 10 mld or 5 mld or 100 mld, calculate the kg of sludge accordingly. So that much huge tons of sludge we are generating. What we do with the sludge? So we are converting simply the phase transfer, right? Whatever the waste in the wastewater, that we are converting again into solid phase, and we need to treat this solid waste also again. So that's the problem. So sludge management is a major cost incurred project. Okay, then secondary sludge, if you think, that will be from the biological process like ASP or trickling filter, there is a sludge. The trickling filter also, if you see the tank, after pouring all the water, it will pass through the filter and it will come out as a big sludges. Like filtration also will happen after this will be scratched off and it will come along with the effluent. That will also be collected. In ASP also we have a secondary settling tank. In trickling filter also we need a secondary settling tank. So this generation will be 70 to 100 kg per million liter of activated sludge. For trickling filter, it will be around 60 to 100 only. So mainly it consists of biomass. There it will be inorganics. Here it will be fully biomass, grown on organic substances. Got it? Yeah. So different stages of sludge, as I mentioned, again primary sludge, secondary sludge or waste activated sludge. That will be first thickened. Various stages of sludge. After sludge got produced, it will be thickened and it will be sent to the digester. So that is digestion. After digestion, it will be dewatered. Finally, the dewatered sludge will be managed properly. You got it? The whole system is called management. Finally, it will be disposed. Okay. First, we need to reduce the volume, that is thickening. Then digestion to make it a proper any leftover organics are there, that will be digested. Then conditioning. After that, dewatering. After that, sludge um, disposal. You got it? The whole chart I will show you in a minute. So the major problem with the sludge is Sludge contains 10% only solids, remaining 90% will be with the water. You got it. So think about the total quantity. If you have 100 kg of sludge, 90 kg will be water, only 10 kg will be your solids. So simply if you put it on gravity itself, 90 liter of water will come out. Only 10 kg will be retaining on the tank. So gravity itself will remove all the water, right? So sludge is not only having solids, it will have mostly water in it, 90%. So volume calculation, if you do, volume of solids will be 0.1 times of volume of total volume, and weight, if you see, that will also be in terms of this. So you can calculate the specific gravity. If you given with the total specific gravity of the sludge, you know the specific gravity of the water, then you can find how much solids in it. You got it? Yeah. To calculate the quantity and what will be the characteristics of the sludge. If you see the primary sludge, that will come from grit chamber, scum tank, that is the skimming tank, it will remove all the scum and grease, and then primary sludge from the chemical precipitation. So screening will be mostly organics and inorganics like plastics, racks, wood, everything will be taken in the screen, right? So based on the screen size, it will get clogged. So that contains mostly organics or inorganic. It will vary based on the seasons. Then grit will be fully inorganic solids because it will settle like sand, clay particles, like that will be settled in the grits, and it will be of high velocity. Relatively high velocity or settling velocity, I'm saying. Okay. Then scum and grease, it will be floating materials like grease, vegetable, minerals, animal fat, wax, soap, like hair, paper, cotton, cigarettes, plastic materials, and all will be floating. That will be taken with the scum and grease chamber, that the floating materials. Then primary sludge from this primary sedimentation tank, that will be gray and slimy, and it will be readily digested under suitable condition because it have mostly organics also, that can be easily digested. Sludge from chemical precipitation will be dark in color, mostly containing iron, because we are using iron as a chemical to make the flocculent sludge, right? So iron will also come with this sludge. We have added, that will come along with the sludge. Then think about the secondary sludge characteristics that will come from biological treatment system like activated sludge process, trickling filter, aerobically digested biosolids, anaerobically digested biosolids, and composting. Think about the activated sludge, it will be brown flocculent, that wasted sludge will be brown flocculent appearance, and it will be septic condition because already endogenous respiration happened and lighter than usual, that may be seen. So it will be very light in color. So trickling filter, if you see, that will also be in brown color, flocculent, relatively inoffensive. But aerobically digested, it will be dark. Order will be of aerobic is not offensive, but anaerobic treatment, if you will see, that will be offensive. And well digested aerobic sludge dewaters easily on dry because we already digested the sample with the whatever the wastewater with the aerobic treatment system. So it will be well digested sample, easy for dewatering. But if you think about other treatment technology, that will have less dewatering potential. Got it? Yeah. So now we are thinking about the sludge management process. All the treatment process will produce sludge. Like primary sludge and secondary sludge are the major classification. We are thinking about the characteristics of the primary sludge and secondary sludge. Yes. Then chemical composition, if you see, the total solids, as I mentioned, only 10%. If you see the primary sludge, it will be 5 to 9. Digested primary sludge, only 2 to 5% of the total solids. Then think about the other 95% will be of water only. You got it. So untreated primary sludge will be 5 to 9%, nearly 10%. This is nearly 5%. And the unactivated sludge will be 1.2% only total solids. So remaining things you think that is water only. Then volatile solids will be surely in 80%. Out of the total solids, volatile will be 80%. Right? Protein will be 20 to 30, nitrogen 1.5 to 4, phosphorus 2.8. In this range, you can think on. Then energy content of the sludge is very high, like 23,000 to 29,000. After digestion, it will be reducing, but untreated primary sludge have lots of energy content. So we can think after removing the water, the dried sludge we can use as an incinerator, like cow dung. After drying, we can use as a energy source, right? We can use as a fuel. Similarly, the sludge also having most of the solids are organic, having calorific value. So think about this point is major characteristics of the sludge. Then quantity. So dry solids per meter cube of 1000 meter cube, 10 power 3 meter cube, right? So 1000 meter cube of water how much kg of sludge is produced? Primary sedimentation, if you see 150, activated sludge only 80, trickling filter 70, right? So 150 is from the primary sedimentation tank. Similarly, extended aeration will produce more because all the nitrogen will also get digested and more time we are giving, so more solids. Then algal removal, similarly suspended nitrification, denitrification process will also produce some quantity of sludge. Primary sedimentation will have more like 150 kg per 1000 meter cube of water treated. Yeah. So here also you can again see the volume, mass of sludge and dry solid contents. This is published data of the sludge production in different European countries. You see Belarus, Denmark, Estonia. These are all different European countries having producing tons of dry solids per year. That is TDS per A. Different countries. If you see, mostly Germany is producing. Think about 2005, 2010, 2020. It's increasing or making it consistent. But Germany is producing almost 100,000, 1,000 lakh, 10 lakh, 20 lakhs of 20 lakh tons of dry solids per year. So if you divide it by 365, you see 20 lakhs by 365. If I keep every day, it's producing 5,500 tons of dry solids. So that much itself from sewage treatment plant. So how they will manage this much quantity of sludge? That's the major task for them. Whether it is organic or inorganic, what are the characteristics, how much water it is there, so how to remove that water. These are all the cost intensive process we have to think about. You got it? So the challenges, that's what I'm going to say now. So any sewage or industrial effluent sludge is a serious problem because it's a high treatment cost, as I mentioned. Another one major problem is if you are not treating and simply disposing in the environment, it has a risk on human health. Okay, so major challenge is how to stabilize the waste because it should not produce any adder. So we have to digest it fully. If any inorganic, easy to dispose. But if any organics, we need to digest it, stabilize it to dispose. And volume reduction. As I mentioned, 100 kg will be sludge. It seems like sludge, but only 1 kg or 5 kg will be sludge. Yeah, the remaining 90% is water. We need to reduce the water content. You got it. So, water content is the major problem with this sludge management. So, if you reduce the water, you can easily dispose it anywhere. If it is not offense, if it's not producing an unpleasant sign, so other you can simply dispose it anywhere. So organic stabilization is another major challenge. Then managing risk like any pathogens are there, any chemicals like ions we have used for flocculation that need to be removed. Then recovery of nutrients, again nitrogen and phosphorus are again going along with the sludge. We need that nutrients, right? So that need not to be disposed simply. Utilizing the energy potential after drying, if you do all this conditioning, you will get again end up with some 10 20 kg, right? So can we use that for any energy production because it's having good calorific value? Can I think about it? That and all major challenges we are having in the sludge management. So now the steps in sludge management you see think about first thickening. So reducing the water content. As I mentioned, 100 kg, 90% will be of water, only 10% will be of solids. Usually we will say 99% and 1% or 99.9% and 0.1%. This much will be of water content will be there in the sludge. So I need to remove this 99% of water. That is called thickening. I am reducing the volume. Then stabilization is what whenever there is any other producing compounds or organic or I mean um, the still partially degraded organics that need to be stabilized. Then dewatering. Any excess water is there that need to be removed. Then hygienization. Hygienization is whenever the pathogen, because it's from wastewater. So we need to think about the pathogens in the wastewater that need to be killed before sterilized before disposing. Then drying. After sterilization, we can dry the waste and we can think about what can we do disposal like incineration, co-composting, land disposal, or energy production. We can think about based on the characteristics. If it is a inert material, we can simply dispose in the land. If it is organic, we can think about co-composting. If it is having high calorific value, we can think about incineration or energy production. You got it? So thickening, after reducing the water content, some portion will be there. That is only solids that need to be stabilized because it's having some volatile. So the out of that half will be removed. That need to be dewatered again. So again, it's 70% will be removed. From that we have to do drying. So after drying, again small quantity of sludge will be there. That itself having huge quantity. That need to be disposed properly, like based on the characteristics, incineration, composting, or land disposal. You got it? So
So,
yeah, please.
so can you explain the flow chart diagram?
This flow chart. Yeah, let me do. Sure. So here, if you see raw sludge from the wastewater treatment plant, where it is coming from, we have primary settling tank, first grid screening, then grid chamber, then primary settling tank, then secondary settling tank. All the primary as well as the secondary sludge is coming in. Then I am going to explain all this process in the upcoming slides. First, we are going to thicken the sludge, then digest. Digestion is one of the process of stabilization. Then lime stabilization we can go. After that, composting, heat treatment is one of the sterilization technique, that is the hygienization technique. Finally, energy from the waste, that is one part of disposal. You got it? So after you can think about this same flowchart. This is one of the adopted method in the municipality, but you can think about any of these combinations and you can try. So composting will also give you again secondary or tertiary sludges. That solids you need to take care. Again, you need to think about land disposal and all. So if you are thinking about both material as well as energy recovery, this combination will work out. You can recover, you can also recover nutrients, you can also recover solids, you can also recover energy out of it. You got it? Anyway, I'm going to explain all these methods in the upcoming slides. This is first, I'm just explaining the route map. uh, Collection, thickening, stabilization, conditioning, dewatering, then disposal. This you just make the flow chart. Okay, understand the flow chart, then we will discuss now. Yeah. So now the various disposal options is like first land-based disposal, fuel-based disposal. Again, sludge disposal option, we have a land-based and water-based disposal systems. So think about this is land sludge use option, this is sludge disposal option. First is benefits and constraints. See, sludge use directly if you are using that on agriculture or reclamation or any forestry as a fertilizer or any reforestation or what we say, um, regeneration of forest. This kind of activities, if you are using the sludge directly, that have a benefits of nutrients because we have a lots of nitrogen and potassium, organic matter in it, low cost. But the problem is we are it's vulnerable to the what we say the ecosystem as well as to the human health and variable demand. We can't supply every day the same quantity. Quality matters. It will not be similar seasonally. It will vary. Impact competition will be there. But if you think about fuel based, like incineration, supplementary fuel for co-combustion, we can do, right? Along with the coal, we can use the sludge as a secondary fuel, as well as gasification. If you do, we will get our green energy. But transportation cost will also be less continuous process. But the problem is public perception. People will not allow you to incinerate anything, right? So if it is a controlled environment also, we can't incinerate any waste. That will have air pollution constraints like emissions. And then finally, after incineration, we'll get ash. What can we do with the ash? Again, it's a sludge, secondary solid waste. So that also we need to take care. The cost for incineration will be higher. Planning controls for emissions and all. And another one issue is the water content. If you are fully dry sludge, if you are having, you can go with the fuel based treatment systems. Okay, then disposal, if you see like landfills, that will have a low cost technology, enhanced CH4 recovery. But another gas emission, if it is not fully lined or covered, and then leachate issue, legacy issue, after sometimes the land will not be used, that will be a loss of land, resource lost. Everything will be lost. Void loss in the sense volume we are what we are using for the landfill, that is fully lost, right? So this much is the landfill means in the land, this much acres, 40, 50 acres will be gone, and along 20 meters of height on the land will also be lost. So void loss, that is another issue, right? Then sludge disposal in the water, like surface waters or any oceans, if you are disposing, that will be again low cost, biological productivity, CO2 fixation, but it has a contaminant in it. Again, it will contaminate the aquatic ecosystem. So we need to think about the sludge treatment process like conditioning, separation, conversion. Conditioning again it will be the chemical conversion or thermal conversion like iron salt, lime addition, hydrolysis. But separation in the sense water and solid we are separating. That's what separation process, phase separation process. Thickening will reduce the water, mechanical dewatering system, drying systems, and then conversion. Conversion is stabilization process or digestion process. Biological and thermal conversion techniques that will convert the remaining organic into some gas production techniques we can use for. Okay, then sludge outlets like it can be integrated with the material cycle, removed from material cycle, like integrated with material cycle in the sense you can use in the land for nutrient recovery. If you are using in the landfill, then material cycle is lost, removal of material cycle. You got it? Yeah. So think about the solids again. Same like wastewater characteristics. The sludge also has a solids are the major characteristics of the sludge. So total solids again we can divide into suspended and dissolved. You all know about this, right? So total solids can be divided into suspended and dissolved. What is suspended? Those who are in suspension in water, that is dissolved in water, that is dissolved solids. Again, it will be classified into fixed and volatile, both. So what is fixed solids? After 550 degrees Celsius in the muffled furnace, whatever the remaining thing that is fixed. Whatever was converted to gas, that is volatilized. Solid is converted into vapor. That's called volatilization, right? The process. So what are the suspended solids that get volatilized? That is volatile suspended solids. What are the dissolved solids that got volatilized? That is volatile dissolved volatile solids. Okay. So again, if you mix both volatile, that is total volatile. If you mix both fixed, that is total fixed. Again, this two will give you total solids. You got it? Anything you can do the material flow analysis. But solids, if you take, sludge, if you take, that contains, as I said, mostly water. So undigested sludge, what is the volatile solids divided by the total solids will be 0.75 to 0.8. If it is a digested solid, so most of the volatile will go off. So 0.6 to 0.65 will be the ratio of volatile to total solids. You got it? So think about the density also. Primary sludge will be 1000 to 1120 to 1030. Similarly, secondary anaerobic sludge will be 1020 to 30. Aerobic will be less dense. Why? Because very fluffy, what we can say, spongy sludges will be, biomass will be settled in the aerobic sludge. But in anaerobic sludge, no oxygen supply. So mostly endogenous respiration will happen. So all the protoplasm will be eaten by on its own. So mostly the formed sludge will be thicker. That's why 1020 to 30. But aerobic sludge will be fluffy. Right. Again, if you thicken the sludge, it will attain the same 20 to 30 kg per meter cube. That is 1.02 tons per meter cube. Then digested sludge, again it will have a 1030 retainment, and the dewatered sludge, again it will increase. After water removal, density will go high, 1050 to 1080. Yeah. If you have a formula for specific gravity of the fixed solids, that is actually 2.5, but specific gravity of the volatile solids is 1. That's why the mixture is having 1.02 or something k tons per meter cube. You got it? Why it's now the solids weight is 2.5, but volatile solids only 1, and water is also 1. So if you mix all this content, the density or the specific gravity is going in this range 1.0 to 1.05. Right? If you have only solids, it will be of 2.5. That's the specific gravity of any soil or solids. Okay, think about the sludge processing. As I mentioned, primary operation, thickening, stabilization, conditioning, dewatering, heat drying, or any drying method you can do, like a bed, drying bed or anything. Then thermal reduction, finally disposal, to reuse or disposal. Okay. Then sludge thickening. If you come with the sludge thickening, that's the first step in sludge management after collection. As I mentioned, 97 to 99% will be water content. So remaining 0.5% is the solids content. That's the dry solid content. 0.5 to 1%. If it is in a secondary sludge, but if it is the primary sludge, it will be 4%. You got it? So sludge thickening will increase. What is the purpose of sludge thickening? It will increase the dry solids content. It reduces the water content. Why? If you have 100 kg, 10 kg is solids and 90 kg is water. If I reduce the water content, then totally solids will be increasing, right? 50-50 now. You got it? That's the purpose of such thickening. Then thickening reduces the volume, improves the operation, and reduces the cost. So gravity and mechanical thickening devices may also be used. I am going to discuss the devices. First, gravity thickener. Simply like the primary sedimentation tank, we have a tank with the arms for mixing that will help you to take out the water from the sledges. So it will slowly turn and the water will come out to the top and solids will settle to the bottom. So that will be the thickening process. Okay. So central feed circulation circular tank that will feed the sledge here, sledge inlet, and then the water will be taken out and the sledge will be taken here. So total sledge volume can be reduced up to 90%. If you pour 100 kg, you will get 10 kg of sledge and 90 kg of water out. Again, that water can be taken out to the treatment plants. So here solid loading rate you have to take care of 90 to 150 kg/ts per meter square per day. That is the solids loading rate. Also, we are loading rate to the tank. So any tank will be having surface overflow rate or solids loading rate. So that will be based on how much kg we are supplying to the treatment system per meter square of area per day. Based on that, we can design the area of the tank. Then dissolved air flotation. So we are supplying air from that bottom in the same sludge thickening tank and it will be mixed always. So the bubble will help you to take out the water and it will come out. The water will come out and the thickened sludge will be taken from the other side. You got it? So the solid particle with the attached bubble have lower specific gravity. So that will go separately and then water will come out separately. Why we are adding air to the solids? Because the solids will be having 2.5 that is the specific gravity of the solids, right? But if I add air to this, air bubble will reduce the specific gravity, so solids will come out along this way. We can also add alum polished electrolytes can also increase the efficiency of the flotation. Again, we have to design based on the solids loading rate in the range of 100 to 150 kg/ts per meter square per day. Then mechanical thickness, see, it has a, if it is used usually in the large wastewater treatment plants, but not cost effective because we need to operate that is simply a tank. But here we need to operate the mechanical arms, need electrical energy, flocculant aid, operating continuously, but that is the only best option. We have different mechanical thickness like screw, drum, belt, and centrifuge. You see, screw that will be having that reducing the screw area. So mostly if it passes, that's on a first it is on centrifuge system they are explaining. So the this there is no size reduction here, the size is same, but if you see here the size is reducing, right? That is a screw belt. This is on centrifuge. The sledge is given as an input and it is turning on a fast speed like a washing machine kind of thing. So all the what we say heavier particle will be forced to the circumference. That's the centrifugation force, right? Simply the same process we are using in the air pollution equipments also, like the air is passed onto a centrifugal pump so that all the heavy metals like heavy particles like solids will be attached to the surface and it will settle, pure air will go out. Similarly, I'm putting salt sludge into the system, it will be moving rotating on a faster speed, so the heavier sludge will go to the circumference and only the water will be coming out. You got it? Yeah. This requires only less space. Instead of thickener, normal thickener will have a big tank, but this requires a small area, land area. And rotary drum thickener, again, if you here there is a filter bed. Okay, so filtering drum. Both sides you have a filtering drum, and feed will be given into this. And while moving in this itself, water will be dragged. So filtered water will be taken out. Again, it can be conditioned along with the polymers. Then belt thickener. So it's moving with the belt. Water will be coming out. You got it? Same like drum thickener. This is a belt thickener. Finally, screw press. So whenever you are having this much area that reduces to this much small area, the sledge is screwed, right? So while screwing, we have a what do we say? A squeezing effect. So squeezing will remove the water content of the solids. Yeah. So here if you see the performance, screw thickener will reduce 4 to 7% of dry solid content, but when it is higher, you can use other things like drum thickener, belt thickener, centrifuge thickener. But if you compare the energy consumption, high will be for centrifugal because you need to rotate it at a high speed, and capacity it can handle up to 200 to 100 for screw thickener and 5 to 200 for centrifuge, right? So comparison of performance again. So centrifugal, gravity belt, drum thickener. Again, these are all gravity only. And DAF, dissolved air flotation. Why? Air will also attach to the solids and it will reduce the specific gravity of the solid and then it can be taken out separately. Right? So you think about the solid capture or efficiency. How much percentage of solid that is captured. It will have higher the gravity 8 to 14. Right. Now we are going with the sledge stabilization and conditioning. After thickening, what is the second step? The undecomposed or partially decomposed organic that need to be taken care. That's what sledge stabilization. After thickening, the second step is sledge stabilization or digestion. Okay, so again we are using here aerobic and anaerobic treatment systems only for sludge digestion because the partially decomposed matter need to be fully decomposed. We need a aerobic or anaerobic system. So sludge stabilization reduces the reactivity of the sludge. That means whatever the remaining organic that will be digested so that the residue will have zero reactivity, right? So what process we can use? Again, biological process only, like it reduces the total mass of the solids and destroys pathogens because if it is an anaerobic system it can also reduce the pathogen content. Anaerobic digestion is preferred for sludge stabilization because the strength of wastewater. If the strength of wastewater is more, what we have chosen in the aerobic and anaerobic treatment system, anaerobic only we have chosen, right? Because mostly we can recover the methane out of it. Yeah, see here, primary secondary sludge. After thickening, it will go to digestion or stabilization tank. There, anaerobic treatment we are doing with the heat and mixing, biogas will be generated. That is used as energy generation potential, and digestion sludge can be used for sent into dewatering. Along with the flocculant aid, water will be taken out, and only the sludge will be going for sludge drying. You got it? Yeah. So again, anaerobic, how we can do the anaerobic sludge digestion? This is not a water, this is a sludge. Okay, so here there is a mixing zone, sludge zone, guide zone, biogas will be there, and effluent we can take out. So sludge we can get here. But here the reduction of organic content is 40 and 50%. And thermophilic digestion by addition of heat, the sludge is fermented in the tank at 55 degrees Celsius. If you are not using temperature, then mesophilic bacteria will act upon and 36 degree will be the optimum range. Mostly it will be taken care with the obligate anaerobes. That is the anaerobe that can live both with the oxygen and without oxygen. Then here 3 phases. But anaerobic wastewater treatment have 4 phases: hydrolysis, acetogenesis, methanogenesis. These are the 4 steps of anaerobic digestion. But anaerobic digestion of sludge have 3 phases. First is liquefaction, that is similar to hydrolysis. Sludge digestion, that is that will also produce gas. Finally, gas production, that is methanogenesis, right? Aceto and aceto they will take as digestion, and methanogenesis they are saying as gas production. Similar to anaerobic wastewater treatment, hydrolysis, acetogenesis, acetomethanogenesis. Okay, here 3 steps: liquefaction, digestion, and gas production. So see, all the again high molecular weight organic compounds will be converted into short chain fatty acids, and then short chain organic compound will be converted into acetic acid, and then that is acetogenesis, and then methanogenesis. Acetic acid will be converted into methane plus carbon dioxide plus other trace gases like sulfuric acid, nitrogen, and hydrogen. Overall, the organic matter will be converted into methane and carbon dioxide, and also new cells will be produced. That will be anaerobic digested biomass, and energy for new cells will be produced. Other products will be H2S, H2, and N2. Again, anaerobic sludge management have 2 steps, 2 reactor setups. One is low rate and high rate. In low rate, we are feeding the sludge, and digested sludge will come to the bottom. The active digestion will happen in the active zone. Water will come up, that is the supernatant, and a scum layer will be there. The produced biogas will be stored in this gas tank and it will be taken out. That is the low rate reactor. But if you think of high rate reactor, there is no distinct layers. All will be completely mixed. So whole reactor will act as an active zone, and then we need to have a secondary tank to settle. Right, the digestion sludge for dewatering we have to take to the secondary tank, but gas will be produced here itself. See, single stage and high dual stage, that is high rate. Single stage we have all the layers like active layer, digester sludge will come into the sludge layer, and then supernatant come gas storage. But here all these things will be mixed. We can supply heat also. Raw water will be raw sludge will be feed into this complete mixing. After that, we need to have a combined the same system, single system we need to have. That there won't be any active layer because all activation is happening here itself. So only settlement we can use this tank. Yeah. See here, then aerobic sludge digestion. As of now, we are seen on digestion by anaerobic system. So that is having again the same steps. But if you think about aerobic system of sludge digestion, similar to activated sludge process, we are supplying substrate is depleted. Supply of available substrate is depleted because in ASP, what we do, air will be passed from the bottom. It will be mixed with the wastewater. Organics in the wastewater will be digested by the microorganism by taking the oxygen. So there will be, we are maintaining the food to microorganism ratio. Food is my substrate, microorganism is my biomass. So substrate to biomass ratio we are maintaining so that there is no fasting condition, there is no feast condition. Similarly, here more substrate are there, but oxygen is low. As oxygen we need to supply very small quantity because aerobic we can't supply that much oxygen in the sludge. Supply of available substrate food is depleted. We are not supplying full food. So microorganisms begin to consume their own protoplasm. Here endogenous phase is happening. Cell component is oxidized. So CO2, H2O, NH3 will be released. 75 to 80% of cell component will be oxidized because the bacteria will start degrading its own biomass. Okay, 20 to 25% will be inert compound that cannot be degraded. Ammonia will also be oxidized here in this aerobic sludge system because we are supplying oxygen. See, any organic matter or microorganism biomass will be added with the oxygen that will give you CO2, H2O and ammonia carbonate. Here there is no CH4. Why? Because we are adding oxygen. It will be aerobic sludge treatment. So sludge cell mass as a formula C5H7NO2 is the formula for the cell mass, any bacterial biomass. So aerobically digested, and this is the major pathway. Nitrification will also happen. So overall we have nitric acid here as a product. Again denitrification will happen, that will reduce to nitrite and then the nitrate and then nitrogen gas. So that's the process. So ammonia will be converted when oxygen is added, NO3 nitrate, then NO2 nitrite, then NO3 after adding oxygen, NO3 nitrate, then after adding oxygen, denitrification process will produce nitrogen gas. Then after thickening, after stabilization or digestion, the third step is sludge conditioning. Why we need to condition the sludge? So that it can be easily dewatered. Okay, so to improve the dewatering characteristics, we need to prepare the sludge for dewatering. That preparation step is called sludge conditioning, right? So for preparation, we can use any salt, minerals, or lime, metals we can use. So utilization of inorganic or organic chemicals or by thermal treatment, we can condition the sludge. Okay, so chemical conditioning in the sense ferric chloride, lime, alum, or conditioning agents used to flocculate the sludge so that it can be easily dewatered. So how much dose of this chemicals required is based on the laboratory trials. We can take the sludge to the laboratory so that we can do different trials to identify the dose of chemical conditioners, right? So sludge condition by thermal treatment, if you see, wet air oxidation and heat treatment. So how much temperature it will go up to 300 degrees, this is up to 200 degrees. So we have a 8 Newton per meter square pressure. Similarly, there 1 to 2 Newton per meter square of pressure. So low temperature and pressure heat treatment which coagulate solids, break down the gel structure, and like all this conditioning are flocculation techniques only. So all the solids will come along with this, it will form a floc. That's called coagulated solids and break down the gel structure. oxidation process which reduces the sludge to ash because it's a thermal treatment, right? And other important advantage of thermal treatment is it will effectively disinfect the sludge because the heat will degrade the pathogens, so it will disinfect the sludge and produces readily dewaterable sludge. Okay, and another one is it will process the cell wall of biological organism and are ruptured, releasing bound organic matter into water. So whatever the cell mass, because most of the sludge will be having biomass only in their cell, thermal treatment will break down the cell wall so that the water inside the cell wall will come out. That will reduce the water content of the sludge. That's why treatment is usually applicable to biological stress, difficult to stabilize or condition by other means. You got it? So sludge conditioning is very required to improve the dewatering characteristics. So next step is dewatering only. So conditioning mechanism, we have added some chemicals like alum, ferric chloride or lime. So what is the good thing with inorganic chemicals, organic chemicals, or the heating? So if you see the conditioning mechanism, this have good mechanisms. Like here only flocculation will happen, but here all the other cell wall breakdown have like hygienization and surface property change, all will happen. Cell split, everything will happen. And sludge mass, if you see, it will increase, inorganic chemicals will increase the sludge mass, but here reduces the existing cell mass because we are breaking down. So solids will reduce. Finally, dewatering, hygienization and disposal. Yeah, if you see here, thickening. After thickening, it's going to stabilization or digestion. After digestion, we are doing conditioning. After conditioning, we are doing dewatering. So why we need to dewater now? Again, the remaining water will be removed. Finally, drying will also be there. Okay. So usually dewater before disposal or further processing we need to do for the digested sludge. Okay. So still contains significant amount of water up to 70%. Now 90% of water was 99% was reduced to 70% in this stage. So here also we need to reduce still further. So sludge drying bed we can use the simplest method that is having a large area footprint. Alternative methods like mechanical like centrifuge and other mechanical dewatering system when we use. In centrifuge and belt filter press, so we are putting the sludge into the filter press, so that will press and remove the water from the sludge. That's another dewatering principle. Okay, again we have a chamber filter press, screw press, relatively expensive compared to the other means. Simply we can do sludge drying bed. If you go to any municipal treatment plant in your area or in NIT also, we have a municipal STPs, 2 STP sewage treatment plant. So we have drying bed. So all the sludge that is collected will be put into this drying bed, that will be drying and a crack will be formed that indicates the complete drying of the sludges. So that can be taken out and we can dispose properly. See here, we have seen this kind of tanks, right? Mostly in the STPs. So sludge drying bed, not drawing, that's a drying bed. Okay, so it's an open bed having sand and stone at the bottom as a supporting layer. So above that we can put the sludge with 70% of moisture content. So majority of the liquid drains off. So we have a perforated pipe at the bottom. So whatever the water that is coming, that will be collected through the pipe and it will be coming out. So first a few hours itself, it will be removing all the water under gravity as well as the evaporation. After that, it will be still operated at 2 to 6 weeks, so that whatever the remaining water content will also get removed by evaporation. Finally, there will be a sludge cake. That cake will shrink, cracks will be formed, that will all again accelerate the evaporation process. You got it? That final sludge cake is ready now. So that can be disposed or used for energy production. Again, if you see the section view of the sludge drying bed, not drying bed, we have a supporting media and a perforated pipe drainage system. First few hours draining will happen, then evaporation will happen, and in the course of time again evaporation drain will happen. Okay, so focusing on the weight reduction, all this sludge management will concentrate on volume and weight reduction by removing the water. Okay, so the disposal cost will be minimum after doing all this. So dewatering increases the calorific value. Why? because all the water is getting removed, only the sludge cake that have good calorific value. If you have directly the sludge with 70% moisture content, the calorific value will be very high, very low. So reduces the probability of leachate generation. That is another good thing. So we are removing all the water. So the dried cake, if you are putting somewhere, leachate problem will not be there. Otherwise, if you are putting directly the 70% moisture content sludge somewhere, the water will come out as a leachate. That cannot be. That's very harmful to human beings, similar to landfill leachate. Right. So other methods we have belt press, polymer conditioning, line. Polymer, why we are adding polymer? That will also remove the water content. Right. So here the major problem with the best is sludge drying bed only. But why we are not using that have a larger land footprint? We need a huge land. 7 days means 7 drying bed kind of thing we need. But in centrifuge and all, it's a equipment or mechanical device to dewater like belt press, filter press. I don't have a image of that. Let me show you. There is a two belt. So the sludge will be moving through this. So that presses the sludge and it will form a cake out of it. So water will be coming out through the filters. That's a press filter. And then finally hygienization. Why we need to hygienize? Because all the sludge will be produced from wastewater treatment plants that have mostly pathogens. Because human excreta may have pathogen, all the other wastewater will have mostly pathogen, sewage only, right? So we need to hygienize by sterilizing the bacteria, disinfecting to remove the pathogenic bacteria adopted by the competing authority. Why we need to confirm the disposal standards? Now, most of the government organizations are releasing toolkits and guidelines for the disposal of sewage and biosolids. Fecal sludge. I have attended a program on fecal sludge management in the CSC Center for Environmental Center for Science and Environment. You can see in Google CSC. They have a toolkit for fecal sludge or biosolids management. So there they have tested all the biosolids or fecal sludges. How can we dispose based on the characteristics? So mostly that will have less toxics, mostly organics that can be easily degraded. But pathogen is a major thing. So we need to analyze the pathogen of that. Got it? Okay. So, but after hygienization only we can dispose in the agricultural land. Otherwise, the edible plant will also get all these pathogens, right? Yeah. How can we do thermal treatment? Like what we can do first one is pasteurization or aerobic thermophilic stabilization. So we can supply air as well as the heat to the system. Similarly, chemical treatment such as lime addition or any kind of this alum addition that will also reduce the pathogenic activity of the sludge. Finally, biological treatment. Again, we are using windrows with bioculture. We are putting sludge in a kind of trapezoidal structure and we are adding bioculture onto that. Again, it will increase the water content, but still it will be taken along with the sludge itself. So, if you spray bioculture, it will stabilize or remove the bacteria in it. Right? Yeah. But if you compare composting, lime treatment, and the pasteurization technique, investment cost will be high for composting, but the energy demand will be high for pasteurization. Chemical demand will be high for lime treatment. Structure material will be high for composting. Again, sludge dewatering needed because composting we are adding bioculture. So again, sludge dewatering needed. Then space needed. Composting will be higher. Hygienization. Very good hygienization will happen in pasteurization. Like same how we are doing for milk. The same we can do for sludge also. Okay. Finally, how can we dispose the sludge cake? Now we are ready with the sludge cake without water or very less water content. So we can think about the calorific value now because most of the sludge solids having calorific value, right? So positive energy balance if you think on, it's the incineration technique, utilization of calorific value. How the amount of sludge generated at the municipal wastewater is very large, very large, right? Because we are having tons of sludges every day. So, but incineration have another problem is air pollution control. That's a major consideration. We have different types of incineration techniques like grate system, fluidized bed system. So we are passing the sludge into the grate, that is a oven kind of thing. So there all things will be burnt and the gas will be taken out. But fluidized bed, it will be on full heat structure. We are passing the solid to float or suspend. That fluidized kind will degrade, what we say, volatilize the waste and gas will be produced. So that kind of incineration technology you can think on. But temperature here is 850 to 1000, here it is 850 to 950 degrees Celsius. See, sludge energy system. We are producing energy, sludge that will be again anaerobic digestion. We have produced gas purification, natural gas system we can use, right? Final disposal on land or on oceans. Ocean, I think nowadays it's banned, but burying underground in a sanitary landfill is good. But how far? Because we need a liner as well as the capping system. So more advanced method of sludge management is putting as a compost or agricultural. Again, the problem is with the pathogen. If you are having full hygienization technique, you can think about as a fertilizer and landscaping. Because it's having good nutrient content, we can use as a additional fertilizer also. I have also published a paper on soil-like material that is recovered from the landfill. How can we use this in the agricultural land? I have tested the seed germination as well as the leachability on the pathogenic activity of this soil-like material, so that it can be used along with the agricultural soil and different composition from 0 to 100%. How it is used in the agricultural land? But my conclusion is, since it's having toxic compound similar to this sludge, like industrial chemicals or something will be there, so it cannot be used for edible plants growth. So we can use in the non-edible plants like sunflower or any other oil production things we can do. Like, you got it. So it's not for human consumption. So that's the whole idea about sludge management. So all the treatment system produces primary as well as the secondary sludge. Sludge management in our treatment system in requires 50% of the total cost of the wastewater treatment. So sludge can be collected. Will have a different characteristic, like primary will be inorganic and secondary will be mostly organic. Secondary will have a aerobic or anaerobic system, have a based on density we can split, and this sludge have mostly 99% water and 1% or 0.1% will be of solids. So that will give you the whole idea. We need to remove the water so we can reduce the volume and the weight. So how can we do? First, thickening. Second, stabilization or digestion. Third, conditioning. Fourth, dewatering. Fifth, this is the drain. Finally, disposal. You got it? So this is the whole idea about sludge management. Right? So if you have any doubt, please unmute and ask, or you can put it in the chat box. Otherwise, we will move on to the problem solving session. Do you have any doubt? Okay. So hope you don't have any questions. If you have any question also, please post it in the chat box. I'm ready to answer in between. Now let me move on to the, yeah, please.
So can you explain the simple process of sludge management?
Sludge management again. You are asking simple process of sludge management.
Like your summary.
That's what I did now, this one. So first we are, as I mentioned, sludge have mostly water, 99 to 99.9% is water. Only 0.1 is solids, right? Because it's from wastewater treatment plant. And we need all sludge management processes cost intensive process. So we need to remove the water. We can use any gravity as well as the mechanical treatment steps. So thickening will first reduce the water to 70%. After thickening, some organics may be in a partially degraded form, that if we can't directly dispose, because it will produce odor. So we need to remove that organics or digest that organics. That's why stabilization or digestion will come. So that stabilization or digestion is based on aerobic or as well as anaerobic process. Again, we can do mostly anaerobic we can do, because it's having high strength solids, right? So we can do anaerobic digestion. After digestion, we need to condition it. So conditioning will help. After digestion, we can go for dewatering, but to improve the dewatering process, we are doing conditioning with some chemicals like lime, alum, or ferric chlorides. Then dewatering will again fully reduce the water to 99% by drying or gravity settling. Finally, we can dispose the cake, sludge cake in agricultural land, or we can recover the nutrients, calorific value, and material out of the sludge. So that's the whole idea about sludge management. But if you're, yeah, please.
Final output is solid, right?
Yeah, final output is solid, but if you are putting it in the incineration plant, you will get ash again that as a solid. And we can recover biogas in this anaerobic digester. But if you are using that in a small STP, you can directly put the sludge in the drain bed. That's what mostly they are doing instead of pressing all these things. But industry level or any corporation level, they are doing, or industry level, they are doing press, sludge press. As I mentioned, between two presses, it will go and it will squeeze the water out and you will get the cake. That cake again they will put in the sludge drain bed.
The treatment is applicable for the domestic waste of water.
Yeah, this all is for domestic wastewater treatment only. The sludge what we have got is, and if it is an industrial sludge, that need to be taken care with a special like techniques. Like if it is only on what we say any electroplating industry, take example electroplating industry, they will use chromium for tanning, chrome tanning they will do. So sorry, I am talking about the leather industry. So leather industry, they will use chrome tanning. So after that, they will produce a huge quantity of chromium that will be of yellow color solid. That will purely heavy metals and solids in it, not organics, mostly inorganics. We can't do any biological treatment. Simply dewater it and dispose it in the pure secured landfill. Or you can think about chemical or heavy metal extraction. After extraction, again you can put it in the secured hazardous landfill, because this is a hazardous waste. As per solid waste characteristics, sludges are considered as hazardous. Even domestic sludges are. So that's why landfill is one of the disposal option. But if it is purely organic and that is fully degraded, I can put it in the agriculture because it's having nutrient content and no pathogens because I pasteurize it. Then agriculture is one of the good option. Agriculture in the sense soil conditioning. Industries like different industries like electroplating and all will produce metal sludges that cannot be done with this type of treatment systems. Yeah. So, okay, done. So can I move on to the problem solving? Please post your answer in the chat box like A, B, C, D. I will read out the questions, please. Okay. Let me move on to the first question. Primary sludge produced from wastewater treatment plant mainly consists of primary sludge, only inorganic settleable solids, dissolved inorganic and organic material, only coarse fraction of organic solids, both inorganic and organic settleable solids.
Sir, your screen is not visible, sir, for the question.
Others?
Sir, for the question which you are reciting, the screen is not visible.
I think others are posting the answers. I think, can you check once? Yeah, visible. Or you can leave the meet and rejoin, sir. Try once.
Okay, sir.
Yeah. Maybe your network issue. Okay. So the answer you are saying is D. Why? Let me take the pen. They are saying about the primary sludge. So sludge will come from, yeah, sorry. Sludge will come from two things. One is primary sludge, other one is secondary sludge. Secondary sludge is from ASP plant or treating filter. Primary sludge is from screens, grit chamber and primary settling tank. Right? Grit chamber and screens will give you inorganics. Primary settling tank will give you settlable organics. So both are settlables. That's why it's settled in the primary treatment system itself. So all are settlable is correct. Okay. Dissolved will be removed only in the secondary settling tank, that is biological treatment. Dissolved organics. Dissolved inorganics we can't do with the primary and secondary. Tertiary treatments are required. Right? So these are the four type of solids we are talking about. So now they are asking about the primary sludge that contains grid and screens inorganics, primary sedimentation tank organic, both are settlable. So both organic and inorganic settlable solids are correct. Right? What is about secondary sludge? Secondary sludge consists mostly organic That is also settlable, but digested organic solid. Biomass, we can say biomass, not the food, that is the microorganisms, settled microorganisms, because microorganism will grow bigger with by eating the dissolved organic matter, and it will settle. The mass will settle. So can you able to see now? I think you are writing.
Yes, sir.
Yeah. Okay, then. Let me move to the second question. So here see, primary sludge consists of settlable solids. Settlable solids, both grid chamber inorganic, sedimentation tank organic. Got it? Yeah. Then second question, which of the following produces waste activated sludge? Waste
So
activated
this is
sludge.
C. This is C, ASP, and trickling filter.
Yeah. Why? Because grid chamber will be not having any activation process, simply gravity settling. Gravity inorganic will be settled, gravity organics will be, this screening also will be organic. Primary clarifier, both are inorganics. Here organics readily settleable. Here only with biological process, we are activating the process. So after aeration tank, all the this is active zone. So in the secondary settling tank, all the biomass will settle, the digested biomass. In this, we are reactivating some sludge, return activated sludge and waste sludge. That is waste activated sludge. So waste activated sludge as a secondary sludge will come from trickling filter or ASP. It's not from multigrade filter or carbon filters. Okay, answer is
Sir, could you explain this trickling filter also? You were explaining for.
sure. So we have discussed about trickling filter in the fourth week. There, the wastewater after primary treatment will have only organic dissolved organics, because suspended organics are removed in primary clarifier. Inorganic will be removed in the second screenings and grid. So only dissolved organic will come after primary treatment. Yes, a central wall will be, a central tube will be there that have a umbrella kind of structure that will trickle or spray the water onto the tank, having pebbles, sand, or any media. So here in ASP, the bacteria will grow in a suspension. That is suspended treatment, suspended growth system. But here the bacteria will grow on the plastic media or on the stone. So it's called attached growth system. So the water will come, the bacteria attached to the media will eat this organics and it will grow. And then the pure water will come out after, because it's having solids, it will filter the water also. After it will move to the settling tank similar to the ASP, it will settle the sludges. So here, after some time, the bacteria will grow, and then inner bacteria will not get any oxygen. So it will peel off. All the layer will peel off. Again, this will come to the tank and it will be settling. So all this will be in the trickling filter. Lots of mechanism will happen like filtration, sedimentation, biological oxidation, and then impaction, interception, everything will happen in the trickling filter. But the problem is clogging of these holes, because it's minute holes that will clog, and any what we say, uh, ponding. If any water is getting ponding in the surface, that will attract insects. So that is another problem. So clogging is the major problem with the trickling filter. So activated sludge will come along with the ASP as well as trickling filter. Yes.
Sir, in trickling filter, this media has to replace then, huh? Once it is,
No, media is inert.
So media is to be replaced
Why
after some
we
time.
need, like, it's a inert media like sand or gravel or plastic media. Only the bacteria growing on
Okay.
that. After some time it will peel off. So no need to replace the media until it get cracked.
Okay.
Yeah.
Until it.
Until it get cracked. Like if we are putting any soil media, then clay soil and all will get cracked, or any mud ball will form. That type you have to replace the media.
Right, sir. Right.
Yeah.
Got it.
If you are putting
Thank you.
any
Sir, it is only present and inorganic substance or organic also is present. In.
solids in the sense, here the inlet water. Are you asking about here or the media?
In the media of the
Media should be inert. Any plastic balls or any plastic media or gravel like stones, that sand, that can be used as a media, not organics. Nothing will be it should be organic, because we are removing this kind of things from the water, so we should not add any. Yeah, okay, let me move on. So again, if you see, secondary sludge will be coming from activated sludge will be coming from trickling filter as well as ASP. Okay, third question, the typical range of organic fraction of solids in the secondary sludge. Secondary sludge will consist of mostly organics only, right? Because biomass. Primary sludge will be containing inerts as well as inorganics, but secondary sludge will be organic. So yeah, it's correct. 60 to 90 is correct. Mostly organics. Secondary sludge. Then fourth question, I am reading two statements. Please go through and answer. First statement is sludge digestion leads to sludge digestion. Okay, digestion is stabilization. Leads to decomposition of organic solids present in the sludge into a stable substance. Because whatever the undecomposed or partially decomposed organic matter will be converted into stable substances. Okay, so that seems correct. Okay, second statement, sludge digestion also significantly reduces the water content of the sludge.
So both are correct, right?
Correct. Yeah. Right. Digestion, they are not asking about the thickening or dewatering. So digestion will reduce the water content. It will actually increase because the cell wall will break down and water will be released during the stabilization process. See here, sludge digestion stabilization reduces the total mass of the solids, not the water content. You got it? So
Okay. Means it will actually it is uh, increasing the solid content and
solid
decreasing the
content.
water.
No, decreasing the solid content
Okay.
because it's digesting. If you are thinking about anaerobic digestion of sludge, you are putting 100 kg of sludge, so water will be as it is. Only the bacteria will act upon the 10% solids you are putting in, so it will convert that into biogas, and 10% will be converted into 5% of solids. Then it will go to dewatering.
Okay, sir. Got it.
Yeah. So solids will be reduced in stabilization and digestion process. Please, other all steps, water will be reduced. Solid will increase. But this step, you can think solids will increase, water content will remain as it is, or we can say it will increase. Okay. Then match this following: lime addition, centrifuge, anaerobic digestion. Think about the aim: sludge stabilization, sludge dewatering, sludge conditioning. So now only we have thought about stabilization and digestion, that is with the anaerobic. So this will match here. Okay. Now lime addition will remove water or condition water. It will condition the water. Centrifuge will remove the water. Okay. So 1C, 2B. Yeah, answer is C. 3A. Is it correct? Sir, B. Why? No B. Can you check the answer, sir? Why B? You mismatched this two maybe. Yeah. It's not about
Sir,
stabilization.
could you explain the difference between this? Dewatering is okay, but conditioning and stabilization, what is the
Oh,
difference?
last one. This is stabilization only, right? Stabilization is digestion. So we can do anaerobic digestion. Stabilization,
Okay.
other name by digestion only we can do. But
Okay.
dewatering you understood, okay? Lime and condition is conditioning. Conditioning can be done. Why conditioning is done? To improve the water dewatering process. So how can we condition? By adding lime, by adding ferrichloride, or by adding alum. So these three are the steps in conditioning.
So, sir, this conditioning is for killing pathogens, na, you were telling here.
That is hygienization. Again, I will
Okay.
explain again. So first sludge will be thickened. After thickening, it will reduce nearly 70% of moisture because it's coming with 99% moisture. After thickening, it will be stabilized or digested, or we can say stabilization by digestion. After digestion will degrade the solids, so it will not have any impact on the moisture. It will reduce the solids, and then it will be putting into the conditioning system. So conditioning also will add chemicals. Then it will go to dewatering system. So dewatering will here in between it comes hygienization. Hygienization will be pasteurization or pathogen killing. Then finally dewatering by drying beds or something. Then disposal. You got the whole process? Yes. So here water will be reduced in thickening. Dewatering water will be reduced. Other in between processes are to stabilize, to condition, to remove the pathogens. You got it?
So this conditioning and hygienization and these are required when we want to use this as a this composting and all in the
Again, there
agriculture.
is a problem. If you are adding any chemicals like ferric chloride and all, that will come along with the sludge. So, can it be suitable for agricultural purpose or not? You have to think. So, conditioning will be done only to dewater. So, if you are putting in the agricultural land directly with the water, also you can put, I guess, 70% removal of water after thickening, after pressing directly, you can put it in the drying and then putting it in the solids. So, if you want to remove whole water, conditioning is required. Like industrial process, they will do the conditioning steps and all. But the municipal
So,
solid waste, adding chemicals to dewater, that is a cost intensive process.
so in practical, I've seen that this while we are using belt filter press or we are using a
Yeah,
centrifuge, we
yeah.
are using this polyelectrolyte as a additive for making the sludge
But that
more.
polyelectrolyte, where it is coming from? Is it organic source or inorganic? That's the matter.
Uh, that I don't know, but that is ionic
Yeah.
poly.
If it is ionic, again, the limit for the sludge, again, you need to do characterization of the dried sludge before disposal into the agricultural field.
I've not used this LM and lime for this.
Yeah.
I have been working in
But
this
ferric
field for.
chloride is common, yeah. Ferric kind of polyelectrolyte is common, correct? Because that will flocculate the solids and water will be coming up. So that will help you in dewatering. Flocculation is mattering here. Yeah.
And sir, why hygienization is needed? Means it,
Again, that matches with the pathogens. If you are disposing in the agricultural land or any land disposal or water disposal, not water disposal, what can I say? Land disposal or agricultural field, what we need, pathogens should not be there. So, if it is having high fecal contamination, then pasteurization or dermal treatment is required.
okay, sir. Done.
That should not contaminate the environment where we are disposing.
Right, sir.
Yeah. Okay. So, moving on to the sixth one. Which of the following processes are expected to result in a significant decrease in the volume of the sludge? Which will have a significant decrease in the volume? Sludge conditioning or sludge digestion or sludge thickening or all the above? Now only we have discussed, right? So which have water reduction? I mean volume reduction of sludge. So volume will be reduced when only um
In digestion, it will reduce na
the
sludge.
sludge will reduce, but significant decrease in the volume will be in sludge thickening.
Okay.
70% will be reduced water. But here only the solids is 1%. Out of the 1%, if 70% is removed also, there is no significant reduction in the whole thing. Our aim for sludge digestion is the organic what we are having in that 1% should be fully decomposed. It's not about the volume reduction.
Okay, sir.
Yeah. So see, sludge thickening will reduce see 97 and 99.5% is water content. That reduction to 70% is our aim in sludge thickening. By gravity settling, thickener itself reduces 90% of the sludge volume. See, this is a significant reduction even in the gravity thickener itself. Yeah. Moving on to the seventh question. In aerobic sludge digestion, digestion again we have anaerobic, aerobic. Anaerobic is the mostly used sludge digestion process because sludge is having high strength organic, right? But aerobic, they are asking aerobic sludge digestion, nitrogen in the cell mass is converted to. We have a thing, right? So ammonia or nitrogen will be there in the cell mass. What is a sludge cell mass? C. What is the formula? Let me go to the lecture materials. Cell formula is C5H7NO2. C5H7NO2 is the biomass chemical formula. So this will be added with the oxygen because we are doing aerobic. So CO2 will be formed, H2O will be formed, and N will be converted into ammonia, and then this nitric acid that will be converted into nitrite because we are adding oxygen. Then it will be converted into nitrate because again we are adding oxygen. Then finally we have uh, denitrification process, that is actually anaerobic. It should be anaerobic, so it will produce nitrogen gas into the atmosphere. So nitrogen is reduced. So here they are saying aerobic sludge crystallization, nitrogen cell is converted into first ammonia, then to nitrite, then to nitrate. So whole process ammonia and then nitrite. You got it? Yes. Ammonia is subsequently oxidized in anaerobic, but anaerobic system will not oxidize the ammonia. Yes. So the primary objective of sludge conditioning process. Why we need to do conditioning? It will reduce the volume of the sludge? No. It will reduce the solid content? No. Disinfect the sludge? No. It will enhance the dewatering characteristics. Right? That's the objective of sludge conditioning. Got it? Yes.
Yes, sir.
So sludge conditioning, the aim is to improve the dewatering characteristics. So ninth question, which of the following sludge dewatering method requires large area? Sludge dewatering in the sense again drying, right? The final step. So we are doing bed, sludge drying bed, centrifuge, filter press, so hydraulic press, which requires larger area. Centrifuge, filter press, hydraulic press, sludge drying bed. Because sludge drying bed again requires 4 to 6 weeks. But this is continuous process. All of this are continuous process. Immediately the cake will come out. But this will take 6 weeks. So out of that 6 week, we need to put the sludge. Every day this much tons of sludges are coming, right? So we need many drying bed. So that after 6th week, I can take out the first tank and I can refill. So until 6 weeks, I need to store it in different tanks. So I need a larger area. So the problem with the sludge drying bed is larger area. The question is which form of dewatering method requires larger area? Sludge drying bed. You got it? So here sludge drying bed, larger area footprint, land area footprint. That's the problem. So 10th question, issue with the sludge incineration. After drying, whatever the cake we are having, that can be incinerated as to that's one of the option, disposal option. And the energy production along with the co-combustion or agricultural land disposal. First is incineration. So what is the problem with incineration? People will oppose always. Land area is not required that much. Risk of air pollution, that is correct, because if not controlled properly, it will contaminate the air because it's a sludge from the wastewater, right? Almost zero calorific of the is wrong. Calorific of wastewater sludge is very high. We had seen, right? 20,000 to 30,000 kilocalories per kg. We need only 1,500 kilocalories per kg to be used as co-combustion. But here we are having 20,000 to 30,000. Even plastics are having large of calorific fuel. That's why waste plastics are used in the cement plant as a co-fuel along with the coal. Coal is having 1 lakh something kilocalories, but this type of sludges are having 20,000 to 30,000. Simply we can use as a co-combustion fuel, right? Our solid waste management rule also mandate every industry who is having kilns, they should acquire 5% of their waste from the nearby refuse derived fuels, like refuse from the agricultural residues or this type of wastewater sludge or any plastic mindful plastic what we are doing in the my project, that will go as a secondary fuel. Got it? So that's a government mandate. So they need, so they are taking from here. But the problem is risk of air pollution is not controlled properly. But anyway, they have to have a air pollution control equipment for coal also, right? So along with that, they have to modify somewhat to stop the emission, right? So the sludge incineration problem is the air pollution control is a major consideration. Some numericals we will try to solve. Okay, simply based on units. You all know water, solid, volume, weight, specific gravity. This is the whole thing playing around. So think about the mechanical thickener. Thickener in the sense it will reduce the volume. You understand? Is a process. Is the mechanical thickening is processing 32,000 kg per day of wet sludge. So I am having a wet sludge 32,000 per kg per day, having 1.2% only solids, right? So 98.8% water, 1.2% solids out of 100% sludge. What is that 100% sludge? That is this 32,000 kg. You got it? Resulting in thickened sludge. So after thickening, I am having 6.4% sludge and 6% water. So I have reduced the volume, right? Why? Water is expelled. So sludges are here you need to know the mass balance. Whatever the sludge is here, the same sludge is here, but the total volume got reduced, so sludge content got increased. It's not like sludge was added. The same sludge was there, only water is removed. Think about 100 kg. 10 kg is sludge, 90 kg is water. So the percentage of sludge is 10%. So I am removing this 50% of water. So now 45% is water. Sorry, again the 10% will increase, right? If you see, this much is my total. Here if you see, 50% is expelled out. So here 50% solids, 50% water. It's not like solid was added. It is water is removed in the thickening process. So what the question they are asking is the total weight of the thickened sludge they are asking. So can I do now? So let me erase. So you understood the concept, right? Solid will remain as it is. Only the water will remove. So first calculate the solids. Out of 32,000 kg per day, 1.2%, 1.2 by 100. How much solids will be there? Calculate 32,000, 1.2 by 100, 384. Are you getting 384 kg per day?
Yes, sir.
This is my solids. Okay. Now, this solid becomes 6.4%. Now, what is my total quantity? For 1.2% of solids, the total quantity is 32,000 for 384 kg per day. The same 384 kg per day, 6.4% is my solid content. What is the back calculation? So, divided by 384 divided by 6.4 by 100. So, it will become 0.0064. So 0.064. So 384 divided by 0.064 because 6.4 by 100. It become 6,000, right?
It become 0.6, no, sir?
No, 6.4 by 100. 0.064, no?
Yes, sir. And we want to divide it by 384 divided by this.
384 divided by 0.64. So you will get
6,000. Okay.
Yeah. Answer is 6,000.
But sir, I could not understand this concept. Could you please explain it again? That concept basic. I understood that the water is that solid content get increased due to
No,
dewatering.
that's the wrong understanding. Solid content is getting increased, but solid is as it is. The total solid. What 10 kg? The same 10 kg is there, but volume basis or weight basis percentage, if you see, here 50-50. Water is 50%, solids is 50%. But here 90% water, 10% solid. But the same solid is here. So 384 kg means here also 384 kg. But here 10%, here it is 50%. So 10% the volume is 3200, but 50% the volume become 6,000. Are you able to get?
Sir, I'm not able to get any other method of I may not be getting you. You are maybe right, but
Yeah, I understood. Now let me clarify with the example. You leave this thing, I will give you one more small numerical, then you will understand. Let me take a 100 kg of sledge. Out of 100 kg of sledge, they are giving the question as the coming 100 kg having 90% water content and 10% solids content. So 10% is my solid content out of 100 kg. So 10 kg, right? So 10 kg here, 90 kg of water. That's why it is 10%. Now the same 100 kg, sorry, not same 100 kg. There is example, same 10 kg here and 10 kg of water. So what is the percentage? 50% of water, 50% of sludge, right? So if I
Yes, sir.
want to know how much total quantity, this total quantity of the sludge, total
This
sludge.
10 kg water and 10 kg sludge.
Yeah, total is 20 kg.
20 kg is
Yeah.
both.
So how I calculate the 20 kg? 10 by 0.5.
Okay. Yes.
You got it?
Yes, sir.
Yeah. Now the same if you apply to the given example, this is 32,000. Out of it, 1.2% is my solids content. So I calculated that into kg. Then the same kg I applied here, but the percentage got different, 6.4%. So if I want to know the total quantity, this one, I need to divide it by 0.06. Or you can do the other way. 6.4% is solids. Remaining 93.7 93.6% is
6%.
water. So calculate this quantity, add both, like 10 plus 10, 20. But easy way is solids by 0.064.
Got your
Or,
point, sir.
yes. So that's the simple way. In thickening, you understand, solid will remain as it is. But in digestion, solid will degrade. That's what we are going to see in the upcoming sums. See. 4,500 kg per day of wastewater sludge is having two-stage thickening. Two-stage thickening. Okay. First is mechanical thickener to reduce its water content from 98.5. So the incoming is having 98.5 water content. After first stage, it will go with 95.4%. Okay. Followed by a centrifuge. So it's a mechanical thickener. Second one is centrifuge. So that will further reduce the water content to 84.3%. Please forgive my handwriting. I am writing with mouse. Okay. And if the specific gravity of the thickened sludge is 1.23, that's the specific gravity of the thickened sludge. The volume of finally thickened sludge would be how much they are asking. You got it. So now 45,000 kg per day, out of which 98.5 will be water. That's the water content. So how much solids will be there? 1.5% is the solids. So calculate in terms of kg. So 45,000 into 1.5 by 100 will be 675 solids are going in. The same 675 solids will come out. Again, after this, same 675 will come out, right? So same 675, 84.3%. What is the total kg? Calculate 675. What I have to do?
Divide by 84.3.
No, by 100. So 0.843, right?
Yes.
Yeah. So answer is 800 kg per day. But they are asking in terms of meter cube. So they given 1.23 as my specific gravity. So what is the density? 1230 kg per meter cube. So I have kg. If I divide it by 1320 meter cube, kg per meter cube, I'll get in terms of this, right? So 800 by 1230 meter cube per day. Did I miss any zero? 4,500 kg per day, out of which is
This is
98,
45,000, sir. 45,000.
yeah, 45,000 into 1.5 by 100. So the solids is 675 is correct. That is converted, followed by a centrifuge to further. Okay. So 675. So again 84.3. So divided by 0.843. Answer is 800 kg per day. So that is divided with 1.23. Let me check one second. 675 is correct. 675 is finally converted into 85.3. So they are asking what they are asking, volume of finally thickened sludge. I am calculating the total volume. Okay. They are asking about the thickened sludge. So sludge is 675 kg only. Right?
Sir,
Sorry, the solids is 675 kg. Volume of finally thickened sludge will be volume of finally. Okay, what we are calculating is correct only. So they are asking finally thickened sludge. So I am dividing it with 4300, 15.7%. 675 will be okay. What I divided 0.875 is my water content,
okay, we have to divide for the sludge content.
solids content. Yeah, sorry,
Solids
my
content.
mistake. So 675. Here we divided with 1.5 only, right? Why we divided with 84.3? So 84.3 minus 100 is 15.7. So divided with the 0.157. So 675 by 0.157 will be 4299. 4299 kg is my kg per day is my sledge, total sledge. So out of that, if I convert it with the density divided by 1230, that 3.495 will be my meter cube per day. So if they given kg into meter cube, you can use the density or specific gravity. And sorry, here the solids I missed. So think about so what we calculated is the water's volume. Okay, it's not the solids volume. Yeah.
What, sir?
Yeah. So answer is 3.495 meter cube. Here, anaerobic sludge digester. So here you have to think about the solid will reduce in weight because digestion is happening. So 1100 meter cube is treating six. This is the 1100 meter cube anaerobic digester. The digester of volume 1100 meter cube. Okay, I am putting a waste 60,000 kg per day. Kg of wet sludge per day. So always draw a diagram. It will be helpful for you. Inlet. Then that sludge is having a specific gravity of 1.09. That is the inlet G. This is Q flow. Okay. Solids content of 4%. Out of his solids is 4%. Okay. The solid fraction of the sludge is 70% organic. Out of this 4%, 70% is organic, 30% is inorganic. You got it? On the sludge. Okay. Then 75% of the organic fraction is converted into smaller fraction. So this 70% of organic plus 75% is converted into gas. Only 25% will come out, and this 30% will always come out because it's inorganic, it's not digested. Based on the information, answer the following question. Can I calculate how much it is everything? First 60,000 kg per day, out of which 4% only solids content. So 0.04. How much it is? 60,000 la 0.04. So 2,400 is my solids kg per day. This solid is digesting. So in this, organic is how much? Inorganic is how much? Organic is 70%. So 2,400 la 70% is into 0.7. I am getting 1680. And inorganic is 2,400 into 0.3, 720 as inorganic, right? So that's just a split up. If you add this, you will get this. So the inorganic will come as it is 720 after digestion, but organic will be digested, right? 75% of organic is digested. 75% is digested. So only remaining 25 will come out. How much will come out? 25% of 1680 is 0.25, 420. 420 kg is coming out. So what is the total sludge now I will get? 420 plus 720.
720.
So I am
1140.
getting 1140 kg out. Okay. Now, but this calculation you please keep. It will be helpful for the upcoming questions. But they are asking first question is residence time of the sledge. Residence time of the sledge, right? I'm having meter cube of the tank. I'm having the inlet cube. It's having day. I need a time. I have the volume. I have the specific gravity 1.09. So it can be converted into 1090 kg per meter cube. So can I convert this inlet quantity into meter cube per day? Then divide it by with this meter cube, I will get day. You got it? You got the unit conversion? I need time, residence time. So it should be in days, right? I have meter cube. I have kg per day. So if I convert this with density, I'll get meter cube per day. Then if I divide meter cube volume with meter cube per day, I'll get day. Right? That's the answer. So what is kg per day? 60,000. How to convert into meter cube per day? By dividing it with the density. 60,000 by
Yes.
1090. Then this value is 60,000 divided by 1090, 55. So that need to be divided with the volume meter cube. What is the meter cube? 1100. So 1100 by 55, 20 days. So the sledge is taking 20 days in the reactor to get digested. You got it? So this is
So,
what
but
the
sir,
wastewater.
all other data are we are not using. So that is just for
No, no. Answer the following question. This is only one question.
okay, okay, right, sir.
Uh, so this is first 20 days. Now we have, you please remember this calculation also. We are going to use in the, so answer is 20 days. So next, second, total dry weight of organic solid in the digested sludge. Total weight of organic solid, dry weight. So water we need to remove. So we have removed water here. Only solids we have calculated. Dry weight of organic solids. How much it is? In the digested sludge. So 420. You got it?
That is 1140, no, sir. Actually, total.
No, they are asking organic solid.
Okay, organic.
420. You got it? So first calculate 4% of the total, and then 30% is organic, and then digest this with 75%. So remaining 30% will come. That is 420. Sorry, this is inorganic. This one, right? Second question, third last same data. Another question. Assuming no reduction in the inorganic fraction, because inorganic will not get digested, right? Any salt or sand will be there, that will not digest. So solid during the digestion, the percentage reduction in the total weight. So what is the total weight we got at the end? 1140. What is the initial weight? 2400. Only for solids I am saying. Right? Here water will be as it is. There is no change in the water weight. So they are asking what is the total reduction in the total weight of the solids. Initial solids quantity is 2400. Now it will be converted into 1140. So what is the reduction? The reduction is 2400 minus 1140 as 1260 divided by the initial is 2400 into 100. That's the percentage reduction. You know the initial minus final divided by initial into 100. That formula I am. Okay. So that will be divided by 2400 into 100. 52.5%. Are you getting?
Yes, sir. It's okay.
Yeah, that's the answer. So thickening, water will go off, solid will be staying. Stabilization, water will stay, solid will reduce. Organics, only organic solid will reduce, inorganic will stay as it is. If you know this concept, you can understand all the sums. Okay. Do you have time? 10 more minutes are there. I will move on to next 10 questions. Yeah. Please answer. Which of the following is likely to be not a major component of primary sludge? Inorganic sediments, dissolved organic, suspended organic, biomass produced from biological treatment system. dissolved, because dissolved organics will be,
So dissolved and biomass both will not be there, na?
yeah, both will not be there. Both should not be there actually. Suspended organic will be there, inorganic sediments will be there, but as per this question, likely not to be. So I hope dissolved organics, because biomass produced at the biological, that should be taken into secondary sludge, but this question they are asking us it. So both answers are actually correct, as you said, but as per the given question, dissolved organic will not settle. So I can say this. Yeah, but both answers are actually correct. As this, waste activate sludge, sand and heavy solids, oil and fat. Again, you can take this as a sand and heavy solids as a inorganic, waste activated sludge as a secondary sludge from the secondary clarifier, sand and heavy solids grit removal, oil and fat from the skimming tank. I think we didn't study about skimming tank. After grit removal or after bar screen or screening, we can put a tank, or in the grit tank itself, we can use the suspended particle removal by a scraper, that is called a skimming tank, that will be skimmed off. The top layer of skin will be skimmed off. That will contains oil, grease, the floatable plastics that passes through the screens, that will be the non-settlable, that floatable things, not suspended. The floated things will be taken off with the skimming tank, like oil, fat. So the answer is 2, 1, 3. A is correct. Yeah, correct.
So generally, it is this skimming is given in primary clarifier in the critical plants. I think I've seen
That
it.
will also be done, like primary clarifier and secondary clarifier also we can do the skimming, because
Mhm.
that it contains biomass also sometimes. Yeah,
That is mixed with sludge only, sir. Matlab,
sludge will settle at the bottom. Oil and grease will
so
come to
we
the
are
top.
we are just skimming from the primary clarifier and we are mixing with the sludge for further
Yeah,
processing.
sludge management will happen with mixer things only. Everything will be mixed. But if you have a different characteristics and different reuse purpose, you can take grits as a separate one.
That's what I'm asking. Is it good to mix it with the sludge? This
Oil and fat, if
skimmed
you
oil and
have any
grease.
reuse purpose, like directly you can use as a, if you don't have any water content, directly if you are using as a energy content purpose, that you can transport separately if you have options to do.
If we do not have option, we have to mix it with the sludge only. I have seen in the practical plants that is mixed with the sludge only.
Yeah,
So it
because
is,
sludge management, again, sludges are considered as hazardous, as I mentioned, as per solid waste management rule. After waste treatment, it will be converted into solids and it will come under solid waste management. So sludge is considered as hazardous, so it will go to the landfills, secured hazardous landfills.
right, sir.
Yeah. And as you mentioned, primary clarifier skimming can be done, but what I am mentioning is the skimming tank. We are using dissolved air flotation method. Bubbles we will float. It will be used in some industrial applications. It has only oil in their wastewater, no other solids or nothing. So to remove that oil, that will be emulsified water. We will say like emulsified in the sense oil, water and oil will get mixed, kind of milk kind of structure. So in that, fat and will be removed by dissolved air flotation. So in that, air will attach with this oil and it will float, and water will be at the bottom. Air will the oil and grease will be at the top, or fat. So this kind of dissolved air flotation or diffused air flotation, small bubbles of air will be diffused from the bottom. That kind of things will also be done in the skimming tank or DAF tanks. Okay. Yes. So the sludge component that does not directly reach the sludge processing unit is, which sludges will not reach sludge processing or management unit? Return activated sludge, waste activated sludge, primary sludge, none of the above.
So return activated sludge will be mixed. So that is the reason.
The aeration tank along with the incoming water. So the answer is return activated sludge will not go to, that will constitute only 5 to 10%. Other 90% will be as a waste activated sludge only from the secondary settling tank. Okay. Yeah. Nice. So here you can see return activated sludge will not go with the sludge treatment. It will go to the aeration basin. Now, volume reduction of the sludge is typically achieved through volume reduction. How can we remove the volume, reduce the volume? By reducing the inorganic solids? No. By reducing the biomass? No. By reducing the organics? No. That is not significant. Reducing water content, because sludge is containing 99.9 or 99% water, 1% only solids, or 0.1% will be solids. So removing 99% will help you to reduce the volume of the sludge. So this is correct. Yeah, that's what we are doing in the sludge thickening process, or any whole sludge management is according to that. Which of the following is not an objective of the sludge thickening process? Sludge thickening. Reducing the total volume of the sludge, increasing the solid content. No, it will not increase the solid content, it will increase the solids percentage. Because volume of the water is reduced, so solids percentage will increase, it will not increase the solids content, right? Reducing the water content of the sludge. Reducing the water content is correct, reducing the total volume is correct. Increasing the organic or inorganic matter ratio of the sludge. This is correct because it's a percentage. Ratio, it's increasing. I'm sorry.
Sir, I think A and C are correct, and these.
A and C are correct, yeah. A and C are correct. They are asking which is not an objective. So compared to this two, I can choose D because organic and inorganic ratio will not be moved with this is happening in the stabilization tank or digestion tank. But they are saying solid content. Actually, it should be solid percentage. They are saying solid content in terms of percentage, so we can accept this answer also. So option D is not the objective of the sludge thickening. Because compared to this two, solid contents in terms of percentage they are saying, so that can be acceptable. See, sludge thickening, the aim is to increase the solid content, dissolved solids content, or dry solids content, reducing the water content. So percentage of this will increase. But remember, solid quantity will not increase. Okay. Yeah. Sludge conditioning can be obtained through conditioning. Iron salt addition, lime salt addition, hydrolysis, any of the above.
So I think lime is weird.
Oh, anything you can do because iron salt also people are doing FeCl3.
Iron salt is FeCl3 same, sir.
Yeah, ferric chloride, lime, alum, and hydrolysis also we can do. Like adding water, I mean, or not water, like it's a kind of what we say, larger molecular substance can be converted into stable, smaller substance. That hydrolysis process may also a conditioning process only. So any of the above we can use. You are about to say something about ferric chloride.
Yes, sir. This was iron compound, but they have written. No? That's what
Yeah,
happens.
but that will also flocculate the sludge and water dewatering can be enhanced, right?
Sir, okay.
So here again two statement. The ratio of volatile and total solids. So volatile solids, total solids indicates the organic fraction. It's correct? Yeah. Because if it is more organic. If it is less, Vs by Ts the ratio is less organic. It's correct. Density of specific sludge sample is typically highest in the raw and reduces with the sludge processing stages. Whether the density will reduce with the sludge processing stages?
Sir, I think it will increase, no?
So, first statement is correct. Second statement is false. Yeah. Because why the density is increasing? Because water is reducing. Specific gravity of solids is 2.5. Specific gravity of water is 1. If you mix both in terms of 99% and 1%, density will be less. But if you mix 50-50, after sludge, it will be increased, right? So that's the concept of sludge management. Yeah. I mean sludge processing stage. See here, the digested sludge is 1030, but primary and secondary sludge are 1020 only. After dewatering, after processing, it will increase 1080 also it will go. And think about the ratio. Digested sludge will be reducing VSCS ratio. So after digestion, organics are removed, so it's reduced. So it indirectly indicates more organics, less organics. That's correct. First statement is correct. Fill in the blanks. Thickening, stabilization or digestion, hydrogenation, drying in between. Oh, there is no conditioning. Actually, it should be conditioning and then dewatering. Or dewatering will be the drying stage, right? So they are saying hydrogenation. As per the given option, I think dewatering is correct. After dewatering, they are doing hydrogenation and drying. Stabilization, dewatering, and hydrogenation, drying. Yeah. As per this order, dewatering, hydrogenation. Actually, the drying is one of the dewatering step. But here dewatering, then hydrogenation and drying we can do. So conditioning also will come in between before dewatering. Yeah. Centrifuge, filter press, belt press are different types of dewatering, conditioning, hydrogenation, or digestive system. It's mechanical only everything. So another one, it's actually a mechanical dewatering system because we are pressing to remove the water, centrifuge to remove the water. So dewatering is correct. Why it's mechanical? What is the other option in dewatering? Under gravity, it's a drying bed. It's under gravity. There is no
It's
mechanical need,
drying
but it
bed.
is having a larger land footprint. Okay. So these are all sludge dewatering, sludge drying bed. Other alternative mechanical methods are centrifuge, belt filter press, chamber filter press, flue press. Okay. Which of the following offers an option to use sludge for energy production? Land disposal, aerobic, anaerobic, both A and B. What can be used to produce energy from sludge? Anaerobic will not produce any energy. Land disposal will not produce energy. Anaerobic will produce CH4.
Methane will be
Methane will
produced.
be produced. Yeah, because of a larger, rich in high strength anaerobic wastewater, or a sludge is also a condition of wastewater only, right? 99% water only. So that can be digested to produce more methane. Okay, right? Sludge, the hydrogenation is primarily the process of reducing the weight and volume. No. Dewatering the sludge. No. Reducing the content of pathogenic bacteria. That is correct. Right? So reducing the content of pathogenic bacteria to an acceptable level to match with the local regulation standards. Some standards are having. I will upload the reading material as a toolkit for biosolids and fecal sludge management. They are having, so it will reduce the pathogenic bacteria accepted to the competing authority. So competent authority will be some Indian standards. I will show you that they have a standard for fecal coliforms, E. coli. So we have discussed in the second week, right? What the third week, quality of the quality characteristics of the wastewater. There bacterial characteristics, biological characteristics we have discussed about coliforms. So that is one of the criteria. 12th question: an apparent disadvantage of using sludge drying bed is land area requirement. Yeah, right. So here again, a simple question: a batch of 4,500 kg of wet sludge. Okay, 98% is water. Is processed, so thickened. Thickening will reduce only water. Sludge will be as it is. So thickened sludge is 1100. What is the water content of the thickened sludge? Can you calculate? So now 4500. How can you approach? Always find the solids, okay, in thickening process, or everywhere you find the solids. 98% water, 98.5% water. So 1.5% solids. So how much it will be? 4,500 into 1.5 by 100
67.5 kg.
kg is my solids. So out of 1100 kg after thickening also, 67.5 kg will be my solids, right? Remaining will be
Water.
67.5 minus 1100 will give you 1032.5 kg as water. So what is the water content? So 1032.5 divided by 1100 is my water content into 100. 93 point. You know what is the formula for water content? Weight of water by total weight. Right. So 93.86. That is equivalent to 94. Somebody posted A. That is correct. Yeah. Thank you. Hope it's clear. Right. Second, again thickening. Thickening solids will stay as it is from the secondary treatment with a total volume of 60 meter cube per day. That's the quantity Q. Total mass is 2750 kg per day is digested in a standard aerobic digestion. Okay, this is the volume of the secondary treatment. Total mass is 2700 kg per day is digested in a standard aerobic digester. Okay, so 2750 kg per day get digested, out of which 75% is organic, 25% is inorganic. Okay, so how much will be organic, how much will be inorganic? Calculate 2750 la 0.75 is organic, so 2062.5 is organic, remaining 687.5 will be kg per day will be my inorganic. Okay, now 70% of the organic is converted into liquid. If it is anaerobic, it will be converted into gas. In aerobic, it will be converted into liquid. So out of 70% got out, it went out of the system, liquid. So only 30% is converted into my solid again. So 2062.5 into 30% will be
618.
618.75. So
Yes,
that's
sir.
my organic solids. Estimate the approximate mass remaining after digestion. So this mass will be there, this mass will be there, the total mass?
619.
No. 618.7 plus 687.5. Total solids they are asking. That have inorganics also, right?
Okay.
So 1306.2, that is nearly equal to 1307. Somebody posted C. Thank you, sir. That is correct. You got it? Yeah.
Sir.
So last question. In the same question 14, if the density of the digested sludge is 1010, solid contents is 5%, what is the digested sludge accumulation rate? So 1010 is my density. Okay. 5% is my solids content. So 95% is my water content. So digested sludge contains both of this. Okay. What is the total quantity? They are saying 1307 is my solids. So 1307 kg per day is my solids. So that solid constitutes 5%. Got it? So what is my total? How I will calculate? Back calculate 0.05 I will divide. Right? So I will get the total quantity as 26140. And this 26140 kg per day has a density of 1010. So if I convert it into meter cube, divide by 1010, I will get meter cube per day as 25.88 meter cube per day. You got it, sir? Yeah. So answer will be 26. Simple back calculation, but I need to know this for 5% is my total solids. Then what is my total quantity along with this 95%? So I will divide this 0.05. So the same what we did in the first question. This is my total volume. 95 plus 5 will give me 26,140 kg per day. If I convert into meter cube per day with the density, I will get 25.88 meter cube per day. Hope you are clear.
Sir.
Yeah. Thank you so much. That's it for today. And if you have any doubt, you can unmute and you can ask, or you post it in the chat box. I'm ready to answer. I'll be in the meet for next 5 minutes. And if you have any doubt, you can leave the meet and don't forget to give the assignments on Wednesday, before Wednesday. That's the deadline. So we are in the 8th week. We have 4 more weeks, 9, 10, 11, 12. After that, we have 1 week of time, 1 or 2 weeks. After then, we have examination. Hope you registered for the examination, I guess. So prepare well. Thank you so much for joining. We will meet next Monday, 6 to 8.
Sir, examination is on November, na? 1st November, I think.
Let me check. I forgot.
November, sir. November.
Yeah, I think so.
It's on 2nd November.
Yeah, might be. course outline, beauty and the course outline. Yes. Yeah, here, November 2. So I think you have registered. So do well. If you don't have any question, you can leave the meet. Thank you all.
Sir, this could you explain this assignment grading? You know how it is. You know, so I have left some assignment I could not complete. So what is
Actually,
it?
it's a 12-week course, right? So you need to score. You need to the best of 8 assignments will be taken for mark consideration. So if you scored 100 in 8, your score will be 100.
But I left with 3 assignment I missed.
No, if you have done already 5, right? So you can do 3 more. That itself enough for your 100% score.
Three,
If
four
you have
already. Three already I have done. Three I think left.
no, it's already 7 weeks over.
7 weeks over. No, so I think four I have done and three I have left.
3 left. So another 4 you can do. That means 8, 9, 10, 11, 12 you have to do compulsory.
That's okay, sir. Sir, if I have any question, because I have been associated with this, wastewater field for a long time.
Yeah,
So
I wanted to ask, sir, actually what you are.
sir, I am, a design person. This wastewater
Oh,
field.
okay. Happy to connect with you. You can mail me or you can ping me on LinkedIn or you
That's
can.
what I am asking. I
Yeah.
connect you because I have some practical questions somehow somewhere.
Sure. Actually, I am from solid waste management, but still I have environmental background. You can approach me anytime.
Sir, I'm core person of wastewater treatment. I have been working for
Sure.
last 20 years in this, and
Thank
right
you.
now I'm doing one project of Indore, that is a that there we will be producing this from digested sludge. We will be producing the CBG,
Okay.
compressed
I think you
biogas.
are attending this course for the first time today, right? This
Yes, I could not join your class because I am working now. Today my health was not good, so
Okay. And
I
my
took.
lectures will be in YouTube. You can follow up anytime, no issue. I will here you can find in the Swayam portal itself the recorded video sessions. In this, you can see the problem solving sessions of July 2025. Mine will be in the Google Sheet. You can go through. Other two PMR scholars also are parallelly taking the courses. Mine will be here surrounded. So last 7 week courses also you can read here.
Sir, you have like explained it very good. I was
Thank you
attending
so much. It's great to hear.
madam's lecture. I was Shiva Sankari madam. I was
Yeah.
attending, and she was also good because see I am mechanical engineer basically. Then I completed my MTech in environmental
Okay.
science.
And you can follow up my paper. I have published one paper on seed germination test and potential toxicity on agricultural field. So that also I
But
will share.
if you allow, I can save your number. You can send me your
Sure.
WhatsApp,
Please,
please,
please, please. You can contact me anytime.
because
Yeah.
now I am lonely with you in the meeting. But anyway,
Sure.
because see, I have some practical questions, and I think you would be able to. You are based in India only, sir.
Yeah, I'm from Tamil Nadu.
Okay, you are residing at NIT only, or
Yeah. I'm
for
now in
doing.
NIT.
Great, sir. I am also thinking of this PhD further, but I MTech result
Let
is.
me talk out of the session. This one I am recording actually.
Yes, sir. Please, sir.
Yeah. Please, you can
Please, sir.
contact
I
me
think we
anytime.
can
Thank you
talk.
so much.
Thanks, sir. Thanks a lot, sir.
Uh,
Thank you very much.
yeah, thank you all. Thank you for joining. Ready to collaborate, and you can. We will meet next Monday, 68. Thank you all. I am closing the
Right.
meet.
Thanks.